practice first reading the table. So I need everybody to do this with me so that if you are not finding these numbers on the table, you can tell me and we can figure out where you're going wrong. So remember, if you forget, if you look up the top, it shows you a little picture of the normal curve, and the area shaded is to the left. So the number on the table is the area to the left. If I want area to the right, what do we have to do? 1 minus that. Okay. So if I ask you for the area to the left of z equals negative 0.38. So I want everybody to go to the table, look for z equals negative 0.38. And what number do you see? B, find the area under the normal curve to the right. So I need to do 1 minus z equals 1.25. So go to positive 1.25.
Wait, question.
Yes.
We do it after we find it?
Yes.
Okay.
So it's 1 minus the number in the table, not the z.
So I'd go to 1.2 and then the 5
Uh-huh.
and then subtract that.
Yes. And what does that give us? 1.05. Everybody find the 0.8944 on the table. Is there another way you could have done area to the right? The negative. Go look up negative 1.25. And what do you have? Yeah. The reason being is this curve is symmetric, so to the right of positive 1.25 would be the same as to the left of negative 1.25. So just a couple different ways you could get it. Alright, find the area under the curve between z equals negative 1.02 and positive 2.94. Alright, let's think about what this means. Negative 1.02 would be over here. 2.94 would be up here. And I want what's between them. We subtract. Look up a positive 2.94. Look up a positive 2.94, your area is 0.9984. So that means everything less than this is 0.9984. Now let's look up negative 1.02. Okay, so that means the area right here is 0.1539. So to get what's between them, we just subtract those two. And what's that give us? 0.445. And the bigger probability has to come first because can our final probability or area be a negative? No. So if you want between two values, you're just subtracting the probabilities. All right. D. Find the area under the standard normal curve to the left of z equals negative 1.32 and to the right of z equals 1.97. Okay, so to the left of 1.32, or negative 1.32, that is the number given on the table, right? So if we look that up, what do we get? Okay, and then if I look up 1.97, we get but I want the area to the right of that. So we have to do 1 minus the 0.9756. That'll give us the area to the right. So 1 minus that is and then, so here is the area to the left, here's the area to the right. What do I need to do with those? Add them up. All right, so I can ask you to find a lot of different things here. We've done less than, greater than, between two numbers, to the left of one, to the right of one. If you're confused on what you need to do, draw your picture and think about it. Okay, we had to find each of those probabilities, this one's from the table, this one the 1 minus, and add them together. Any questions on that one? Try another one. A pediatrician finds the heights of her female 3-year-old patients are normally distributed with a mean of 38.72 inches and a standard deviation 3.17 inches. Find the proportion of 3-year-old females with a height less than 35 inches. So I'm finding the proportion or the probability that the height is less than 35. Okay, can I look up 35 on my normal table? No. What do we have to do? We need the z-score. Okay, how do we find a z? X minus mu, so our value minus the mean, divided by the standard deviation. We want to go to 2 decimal places for this, because that's what our table allows. So I get a z of negative 1.17. So the probability that x is less than 35 is the same as saying the probability that x, or that z, is less than negative 1.17. Okay, doesn't our table give us less than? So now we go look up negative 1.17. So B, I want the probability that the height is between 35 and 40. So 35 less than x less than or equal to 40. And technically with the normal, it doesn't matter if it has equal to's or not. It's the same probability. So what do I have to do? Yeah, we need the z for both of them. We already know the z for the 35 because we found it on part A. So finding our z for 40, so x, so our value, minus the mean, divided by the standard deviation. So we get a z of 40. All right, if you're finding between two, what are we going to have to do with the probabilities? Subtract them. We have to make sure the bigger one is first. So the 40 would be the bigger one. So the probability of 0.4, so positive 0.4 is 0.6554 minus the probability of the negative 1.17. 0.1210, and we get
It's about this.
So next question, I'm asking you to work backwards. We're finding the z-score. So we're finding that bold number on the outside of the table, such that the area to the left is 0.1. So that means in my table, this is 0.1. You have to tell me what the z is. So table gives us area to the left. So this time you are looking inside the table at these probabilities. We are trying to find the closest we can get to 0.1 for a probability.
So the 0.9998.
That would be the closest to 1. We want 0.1. So if I'm looking on here, I want 0.1. So if I'm looking these, the closest we come to a 0.1. Okay, and where are we? So I'm looking in my table, so we have a 0.0985. 0.0968 is closer. What about 0.1003? Is there anything closer than 0.1003? No. Does everybody see that number in your table? So now you are trying to find the z that gives that to you. So if I'm looking here, yeah, negative 1.28. All right, so everybody see how I found that? So we were looking inside the table and then giving the z that matches it. Okay, let's try another one. So if I want the area to the right to be 0.25, so if you think about your normal curve, the area to the right is 0.25. Is that the area I will look up on my table? No. 1 minus that is 0.75. So we need to find the closest area we can get to 0.75. So if I'm looking, as we go down this table, my areas are getting larger. So I am looking for 0.75. Yeah, we have a 0.7486 and a 0.7517, right? Which one's closer? Yeah. So if I look, that's the closest my table gives me. So my z would be 0.67. Did everyone find that? You're also free, if you notice that it is, these two are practically equal distance from 0.75. So if you wanted what's in the middle of 0.67 and 0.68? 0.675. So you're welcome to do that as well. Sometimes it is exactly in the middle, so I'll probably do it on those. When it's not perfectly in the middle, a lot of times I just pick the closest one, but you could give me either on that. All right, C. The middle 99% of the distribution is between these scores. Okay, this is tricky. So I want 99% to be in the middle. So I have 1% left to split over two ends. So what's this probability? 0.005. Okay, this little tail over here is also 0.005. So we have to find our z's. I think all of them have the same questions. It was just depending on the version where they had different ones there. So you can check the questions and then do them each of the solutions. So,
One for each one.
yeah, so like make it out of 21 points. So they get 1 point per question and then 1 point per choice.
Thank you.
You're welcome. Okay, so if I go to my table, first let's look at for the 0.005. So that's going to be closer to the top. 0.00. I have 0.0051, 0.0049. So isn't it right in the middle of those? So that is negative 2.57 and negative 2.58. So what's in the middle? Do you have any guesses for what the other z value is without me looking at it? Positive what? 2.575. So if we have 0.005 to the right, that means it has 0.995 to the left, right? If I went to my table and I looked at 0.995, it's right here in between 2.57 and 2.58. So you are correct. Because this is symmetric, if you have the same amount on both ends, it's just the positive and the negative. All right. Questions on that one? Let's look at this question. The combined verbal and quantitative reasoning score on the GRE is normally distributed with a mean of 1,049 and standard deviation of 189. What is the score of a student whose percentile rank is at the 85th percentile? All right, what does it mean to be at the 85th percentile? We've done percentiles before. Means 85% are less than or equal. So the probability of being down here is 0.85. So what can I look up now? If we know the probability, can we find the z? So we're going to our table. We're looking up the closest we can get to 0.85. So it looks like I have a 0.8485 and 0.8508. So 0.8508 is the closest, and that is at 1.04. So now I know my z. I want the student's score. So think about how a z is found. It's x minus the mean divided by the standard deviation. The z is 1.04. We don't know x. The mean was standard deviation 189. So now we can solve for this. We get 1245.56, or they got about a 1246 on the test. Look at some more. It is known that the length of a certain steel rod is normally distributed with a mean of 100 centimeters and standard deviation of 0.45 centimeters. Suppose the manufacturer wants to accept 90% of all rods manufactured. Determine the lengths of rods that make up the middle 90% of all steel rods manufactured. Okay. So they want to keep 90%. Does that mean they just want to get rid of the biggest 10%? No, they want to keep the 90% that is closest to average. So they are going to get rid of the smallest and the biggest. If 90% is in the middle, what's the percent on each of these? Yep, so this is 0.05. All right, so let's find those z's. So when the area to the left is 0.05, so you're going to your table, you're looking up 0.05. So that's the probability, that's inside the table. So I see a 0.0505 and 0.0495. So it'd be right in the middle, so it's 1.645. So negative 1.645. So what would be the z over here? It's the positive. All right, so now I know my z's. What am I trying to find? The x. So we know that z is x minus mu over sigma. So negative 1.645 equals our length minus the mean divided by standard deviation. Multiply over the 0.45, add over the 100. Do that for both the z values. So that means they will keep all rods between 99.26 centimeters and 100.74 centimeters. Anything smaller than the 99.26 or bigger than the 100.74 would get thrown out. Any questions so far? 2 examples left. The last thing is just a notation, and it's kind of annoying because it's the opposite of what the table gives us, but I didn't write stats, so this is not my decision. So the Z alpha notation, when you see something written like that, alpha is the area to the right, and our table is area to the left. So they are opposites of one another. So if I ask you to find the value of Z.10, okay, whoops. So that means, if we're looking at a table, we have to find the Z, so that's what we're looking for. The area to the right is 0.1. So when I'm looking in my table, what area am I going to look up? 0.9. And we're looking for the Z that matches it. So we're inside the table when we find a 0.9. So the closest we can get, 0.8997. And so that Z is 1.28. So just know when it's written like that, that 0.1 is area to the right. You have to look up the area to the left. Do we need another one like this? Last question. Suppose a random variable is normally distributed with mean 50 and standard deviation of 7. Find each probability. So what am I going to have to do each time? Find the Z. So my X is 35, mean is 50, standard deviation is 7. So the first one, we're finding the probability that Z is bigger than negative 2.14. How do we do greater than? 1 minus. This time I gave you Z, so we are looking up when Z is negative 2.14. What's the probability given? B, less than or equal to 45. Does the equal to change anything? No. So find our Z. X minus the mean divided by standard deviation. Negative 0.71. So we're finding the probability that Z is less than negative 0.71. Less than is what our table gives us. So if we go to negative 0.71, we get and the last one, how do we do between? Probability that our Z is between these values. We know our final answer has to be positive, so you look up the bigger probability first. So we start with the 2.14, and that probability is minus, and you look up the negative 1.43. So this is the end of 7.2. You guys have that homework packet. So I would like it done Monday. I'm probably going to take Monday and do a little more practice with this chapter before I move into the next one. So we'll have a little practice time Monday and then Tuesday we'll start.